Hi, this is Mr. Rashid, and today's learning objective is I can write linear functions. So last time we were looking at, very specifically, we could take equations and draw some graphs from it. And we had many types of equations that we were looking at, and we could draw the graphs. So today we're going to look at, for this particular learning target, we're going to look at taking situations, which are word problems, tables, and graphs, and turning those into equations. And we're looking at specifically linear functions. That's the type of equation that we're creating. So let's get started. The first example we have here is an multiple choice type of question from the ACT. So here it's saying, when graphed in the standard XY coordinate plane, which of the following equations does not represent a line? So let's think about it. We have seen horizontal lines, vertical lines, and also lines in standard form, point slope form, and also slope intercept form. So let's go down this list. So x equals 4. This says that x is always 4. So that's something like 1, 2, 3, 4. And we have a vertical line at x equals 4. So that's an equation of a line. That's perfectly fine because we want to find what does not represent a line. Then the next one here is 3y equals 6. Let's convert it into a form we can work with by dividing both sides here by 3. We end up with y is equal to 2. And so with y is equal to 2, y is always 2. Here's 1 and there's 2, so this is y equals 2. So that's perfectly fine. That is an equation of a line. That's a horizontal line. The other one, x equals 4, was a vertical line. So now we have x minus y equals 1. And this looks perfectly fine. This looks like an equation of the form ax plus by equals c, and where a, b, and c are integers. So anything you can write in standard form is a line. Anything you can get into this form, if you ever have something you're trying to rearrange and get it into that form, that is a line. So that works out. And then this choice D is y equals 3/4 x minus 2, and this is very much like a standard equation in slope-intercept form, which is y equals mx plus b, where m is your 3/4 and your y-intercept is this negative 2. So that is a line as well. And then that brings us to choice E, and the thing that makes it not a line is this x squared, and specifically this power here. So something raised to the second power. So anything like that will not result in an equation that gives you a line. In fact, if I move things around here, so if I subtract x squared from both sides here, end up with y equals negative x squared plus 5, which is a quadratic function. So the one that does not represent a line in this case is choice E. So that's what we would select here. Okay, let's move on. All right, so the very first case we're going to look at here is a situation, and we are turning this situation into a linear function. So there are different kinds of situations. This situation happens to be a y equals mx plus b type of situation. And these types of situations, you can almost rearrange this and think of it as y equals b plus mx, and this can be thought of as your start. Where does the situation start? And then this part here, this m, can be thought of as how does your situation grow, or how does it decay? And now there are many types of functions that grow and decay, but with linear functions, you're looking at a constant growth or a constant rate that it's decaying or decreasing, or somehow the numbers are going down. So in this case, we have a movie trailer offends 45 people in a theater, and then the feature movie disturbs 25 more people every scene the villain appears in. So what we have is a starting value of 45. That was the number of people offended right at the beginning. And then we have a constant growth rate of 25 people for every scene the villain appears in. So our growth rate is the 25, and we put an x next to it, and we get y equals 45 plus 25 times x, or if we rearrange this into our standard slope-intercept form, we get y equals 25x plus 45. And then sometimes in these questions they'll ask, what does the x represent or the y represent? So we have the x representing the villain scenes in the movie, and y is the total number of people offended. So this would be right there. Okay, let's move on. So here there's just a blank slide. So we're going to be looking at other cases now of converting situations, tables, and graphs. We're going to be converting those into functions. So it really depends on the situation. So that was an mx plus b situation we saw with that movie theater and the villains and the scenes. There are other situations that we'll talk about in class that are more, it's better to use point slope form, or it's better to use standard form for those. So let's just review what these are again. So standard form is ax plus by equals c, where a, b, and c are all integers. And the main thing we can think of is that none of those can be fractions, so no fractions for this. And then also in our book, it assumes that a is positive, so a is greater than 0. Then we have slope-intercept form, where m is the slope and b is the y-intercept. And then the third one here is point slope form, where we have a point that we know about, that is x1, y1, and then the slope is very similar to, it's got the same name as the slope-intercept form, it's m, and that's right there. And remember, for the x1, y1, we're using the opposite of what you see here. So that's negative here, so the point is a positive, and sorry, the point is a positive, and then here this is a negative, and then the point is positive. So it's going to take the opposite value. Now this is another very useful equation. This allows us to calculate the slope given 2 points. So if we have an x1, y1, and an x2, y2, then we can use this equation to find the slope. And that helps us sometimes when that's the only way we can get that. And then the last thing here is that, remember that anything but the vertical line is a function, and we can write the function in this form: f of x is equal to mx plus b. So x is our input and f of x is our output, and this type of thinking comes in handy when there's no other way to calculate maybe b or the m, and then we have to use our inputs and outputs to figure out what those values are. All right, so let's see some examples. Okay, before we see the examples, let's just cover the special cases of the horizontal line. So if I have a horizontal line, let's say going like this, right? Just to remind ourselves, that has a slope of 0, and any point that I take on that horizontal line, right? In this case, every single one of those points, right? It doesn't matter what the x value is, but the y value of those is going to be 4. Right? So no matter where I go on this line, my y value is 4. So this is a special type of line, and I can write y equals 4, or f of x is equal to 4, and that is the equation or the function for that particular line. So y is always equal to 4. Now what about vertical lines? So vertical lines, the slope of those is undefined, and let's take an example of one here. So this one is 7. So x equals 7, and you'll notice that no matter where I am on this line, x is always equal to 7. Let's get into the examples. Okay, so I'm going to write linear functions. So write the equation of the line with the slope equals -3 and y-intercept 12. So we always, in these type of examples where we're writing the equation for the lines, want to pick the most efficient way that we can get there. And when given the slope and the y-intercept, there's really the fastest way to do it would be to use y equals mx plus b, where we can plug the slope in there and the y-intercept in here, and we're done. We have the equation of the line. So this becomes y equals -3x plus 12. And that's it. That's the equation of the line. So let's take a look at now this one here. Write the equation of the line shown. Now here there's lots of ways to do things. So one of those would be to use, let's say, y equals mx plus b again. And with this, now we need a slope, and we also need a y-intercept. So just reading off here, the y-intercept, this is 0, 7 is the y-intercept. So we know then our b value here is going to be 7. Now what about the slope? So here I notice this is all, if I go up, that's 7, and if I go this way, that is 5. Now, does this line have a positive or a negative slope? And the way I think about that is I imagine I've got a snow border, and this snow border can only go from left to right on a piece of paper. And this snow border thinks that this is a really nice line because it's smooth sailing and it can go down this hill. So this is a nice negative line for them. And so we have a rise of 7 and our run of 5. So, and this will be a negative line, a negative slope line. So the slope is -7/5 x plus, and we said our intercept was 7. So this is the equation of the line.